Hello to everyone. In today's video, we are going to be looking at partial fractions. Now, this question is taken from GCE Mathematics June 2021, question 1 sub 1. The question says, express 5x divided by x plus 3 into x minus 2 into partial fractions, 3 marks. Now, we may ask to express this, but before we get into the video, we are going to do a brief review. If we are given our fraction, let's say f of x divided by g of x, we have to check if it is a proper or an improper fraction before we proceed in expressing it into partial fractions. Now, how can we do that? We simply do that by comparing the coefficients, the degree of the fractions. Now, the degree here, when we talk of the degree, it simply means the highest power of the numerator or the denominator. Now, the first condition that we might look at is if the degree of f of x is strictly less than the degree of g of x. Here, what do we have? We have a proper fraction. Here we have a proper fraction. So we are free to go directly to partial fract it. Now, what if the degree of f of x is greater than or equal to the degree of g of x? In this case, what we need to look at is here will be an improper fraction, and to partial fract it, we simply need to put it into proper fraction before partial fracting. Now, there are various ways in which we can put that into. So the first condition or thing, the first thing we need to note is when we have an improper fraction, we transform it into a proper fraction, then we partial fract. By simply, to know if it has been transformed, we simply compare the degree of the power. Now, there are various ways in which we can transform an improper fraction to a proper fraction. The easiest and the most used way is by long division. So we are going to see this in our previous or in our upcoming videos, where maybe probably in further mathematics, where we are given a partial fraction, an improper fraction. We need to simplify it using long division, and from there we can have a proper fraction. From there we partial fract. The second thing I want you guys to take note of with partial fraction is, let's consider a partial fraction. Let's say I'm going to consider z to be a constant. Let me say if we are given a constant z divided by x plus 2 into x minus 1. Here, to express this, the first way to do that, we have a divided by the denominator, the first, plus b divided by the second. In this case, since z is a constant, now if we have a partial fraction, let's say z divided by x squared plus 1 times, let's say, x minus 2. In this case, to express this into partial fraction, first of all, it is proper because the degree down is 3 and the degree up is 0. So 0 is less than 3. Therefore, it's a proper fraction. We simply go directly. Now, if we look at this carefully, it's in the form of a quadratic. So we have ax plus b divided by x squared plus 1. Plus, here, we have c divided by x minus 2. And finally, the last condition, if we have, let's say, z divided by x plus 1 all that squared times x minus 1. Here, this is equivalent to a into x plus 1 plus b into x plus 1 all that squared plus c into x minus 1. So when expressing a fraction into partial fraction, we have to have these two conditions, or these two reviews that I've just illustrated. You have to know the form of the partial fraction, and you need to know the degree of a fraction, because if you just get into a partial fraction and start solving, at the end you might not have your answer, since it is an improper fraction, and you need to bring it to a proper fraction for you to be able to use these conditions to solve it. So with this in mind, we're going to apply the same idea to solving our partial fraction. First of all, we verify if it's a proper or an improper fraction. The highest degree in the numerator is 1, because this is a linear function, and the highest degree in the denominator is actually 2, because you expand these fractions. If we expand this function, we're going to have x squared minus 2x plus 3x minus 6. So the highest power there is 2. Therefore, we have in the numerator have 1, and in the denominator have 2. Since 1 is less than 2, therefore this is a proper fraction. So we are very free to go ahead and simply express it. Now to express it, we already saw the conditions. So since this is a linear function, we're going to use a constant a divided by x plus 3. Now since here also is a linear function, we're going to use a constant b divided by x minus 2. Now we have to take note that the denominator here is supposed to be the same as the denominator in the original fraction. So we're simply going to copy that x minus 2. Make sure that this and this are the same. Now, if we take the denominator and we bring it, we divide by x plus 3, we are going to have x minus 2. So here we have a into x minus 2. So if we do the same thing here, we're going to have b into x plus 3. Now we're going to compare this, because remember, this was 5x divided by x plus 3 in x minus 2. Comparing our numerator and the denominator, since the denominator here is the same as the denominator here, the numerator should also be the same, since we're apparently dealing with the same fractions. Remember, we want to express this in another form, or in a much simpler form. So it means that our 5x will simply be equal to a into x minus 2 plus b into x plus 3. We're going to call this our equation star. Now to look for the value of a and b, we have to use either substitution or we compare coefficients. So the two methods that we're going to look at in this video is, the first method is method 1. Using substitution. So using substitution, here we need to let our value of x to be another value, such that when we put in our original equation star, it should cancel one of our variables, either a or b. So looking at this equation star carefully, you see that if we let our x to be let me say minus 3, this is the first condition, or this is the first substitution. If we let x to be minus 3 in equation star, we notice that minus 3 plus 3 here, this is going to give us 0, right? So it's the same thing. We're going to have 5 into minus 3 to be equal to a into minus 3 minus 2 plus b into minus 3 plus 3. What are we going to notice? This is going to give us 0. So our equation, our original equation, or our equation is going to be minus 15 to be equal to minus 5a. Now dividing all through by minus 5, this is going to cancel. This is going to, so our a is going to be 3. And this is our value of a. Okay, doing something similar for question using another substitution. Now we're going to look at another value. Now let x be equal to 2 in this case. Why 2? If I put 2 here, it's going to cancel. Therefore, I'm going to have 5 into 2 to be equal to a into 2 minus 2 plus b into 2 plus 3. Here, clearly you see that when we substitute, this is going to give us 0. So we're left with 10 to be equal to 5b. Dividing all through by 5. 5 is going to cancel. Our b is going to be 2. So having our value of a and b, to get our partial fraction, we simply substitute it here. So doing that, we're going to have our a is 3. So we're going to have 3. We're going to have 3 divided by x plus 3 plus b, which is 2, divided by x minus 2. So this is our partial fraction. This is our partial fraction. So if in the exam, normally it should end here, but just for clarity or to expand the video, I'm going to solve using method 2 and see if we're going to have the same answers at the end. And I will give a tip at the end of the video, something that you need to have in mind when solving any partial fraction. So now let's look at method 2. Now method 2, using comparing coefficients. So in this case, what we need to do is simply we expand the right hand side and we compare the coefficients. So expanding our right hand side, we're going to have in the left hand side we have 5x to be equal to, expanding this, we're going to have a times x, we're going to have ax. A times minus 2, we're going to have minus 2a, plus doing the same thing for b, we're going to have bx plus 3b. Here we have 5x. We can look at this as 5x plus 0, since 0 is a constant. Here we simply bring our like terms together. So I have 5x plus bx and minus 2a plus 3b. We see that this is our constant term. This term, these are the terms in terms of x. So we have 5x plus 0 to be, x is common. So we have a plus b into x minus or plus negative 2a plus 3b. Now comparing our coefficients, what are we going to do? We notice that the coefficient of x on the left hand side is 5. Therefore, the equation of x on the right hand side should also be 5. It means we're going to have a plus b to be equal to 5. This is our equation 1. Now we'll do something similar to the other constant. Since our constant on the left hand side is 0, therefore the constant on the right hand side should also be 0. It means that minus 2a plus 3b should be equal to 0. This is our equation 2. This is simultaneous equations, or these are simultaneous. This is a simultaneous equation, and we know the various methods in which we can use in solving a simultaneous equation. We can use substitution. We either make one of the variables subject in equation 1 and substitute in equation 2, or we vice versa, or we simply go by elimination. I would prefer elimination in this case. So what's the first thing we need to do? For elimination, we're going to take our equation 1 times 2. It means that our equation 2, our equation 1, by substituting this here, means we're going to have 2a plus 2b to be 10. So these are equation 1 star. We're going to use equation 1 star with equation 2. So using equation 1 star and equation 2, we're simply going to take equation 1 star plus equation 2, equation 1 star plus equation 2. We notice that 2a plus minus 2a here is going to cancel, so it's going to give us 0. So 3b plus 2b here, this will give us 0 plus 10. Therefore 5b will be equal to 10, which implies b will be 2. So we have our value of b to be 2. We can simply substitute this value of b equal to 2 in our equation 1. So b equal to 2 in equation 1, we have our equation 1 says a plus b, right? A plus b equal to 5. So a will simply be 5 minus 2, which will be 3. Therefore a will be 3. Good. Having b to be a is 3 and b is 2. If we substitute it in our original fraction, we're going to have 3 divided by x plus 3 plus 2 divided by x minus 2. So giving us the original value that we had, or the original partial fraction that we had before. Now, in order to be very sure of your answer, because in some questions, what I'm going to do is that after expressing it to partial fraction, you'll be asked to integrate it. Maybe you'll be given a range of values or a bound. Now, to do that, you have to first of all verify if your partial fraction is correct or not. To do that, we're going to use substitution. Or we're being asked to express this partial fraction into partial fraction. So normally this fraction, this our partial fraction, should be the same as the original fraction. Therefore, to verify that, we have to use substitution. If we let x to be equal to 1. Now, before letting a value, you should be careful that you choose a value that is in the domain of that function. In this case, the domain of this function does not include 2 and minus 3. Why? Because we put 2 here, it's going to give us 2 divided by 0. The same thing here, 5 times 2, which is 10 divided by 0, is undefined. Therefore, we need to choose a value in its domain. Now, substituting x equal to 1 in our original fraction, let's start here. We're going to have 5 times 1 divided by 1 plus 3 into 1 minus 2. So here we're going to have 5 divided by 4 times minus 2. 4 times minus 1, because we have 1 minus 2, which is minus 1. So this is going to give us minus 5 on 4. Now we're going to do the same thing here. Doing the same thing there, we're going to have 3 divided by 1 plus 3 plus 2 divided by 1 minus 2. So it means 3 divided by 4 plus 2 divided by minus 1, which means that we have 3 divided by 4 minus 2 divided by 1. So the LCM here is 4. We have 3 here minus 8 here. So this is simply the negative 5 on 4. Now let's look at this value and compare it with its other value. Since they are the same, therefore our partial fraction is correct. Once you're able to verify this in the examination hall, it means you're very sure that you're going to get all the marks that are allocated to that particular question. It is very, very important to always verify this. Remember, in some questions you'll be asked to actually do something further, integrate it, or maybe substitute a value. So that is it for this video. If you found the video helpful, consider subscribing and turning the bell notification on, so that whenever I upload new videos, probably in all the subjects in chemistry, physics, mathematics, further maths, mechanics, and even statistics, you'll be notified. So make sure to subscribe and turn on the bell notification. Also, consider liking the video so that it can help in the YouTube algorithm, so that the video can reach to more people, and it's also a form of supporting what I'm doing. And consider sharing it with your classmates so that they can also benefit from the knowledge in this video. So download the complete GC equation in the description box. There's a free downloadable link to the equation in the description box and also in the comment section. So see you in the next video.